Assalamualaikum warahmatullahi wabarakatuh. Today, I, Zulkurnain Hassan, and will present the research that I have doing with my SV is Dr. Muhammad Sofian and Dr. Nancy. Our top title of the experiment is the research is experimental performance analysis of direct evaporative cooling. We are from Faculty of Engineering, UMS Sabah. For first of all, I will introduce the topic, the title of the topic today. Air temperature is gradually increased day by day due to global warming, make it uncomfortable to stay in room without a proper cooling system. Room with temperature of 25 degrees Celsius and 55% relative humidity is considered to be under comfortable zone. Evaporative cooling may offer an alternative to mechanical refrigeration cooling for air conditioning. The evaporative cooling is an energy saving and environmentally friendly cooling technology where the heat is absorbed and the air is cooled through the water evaporating process. And evaporative cooling is energy saving because the only power consuming component are fans and water pump. By only use water as a working flood, the evaporating cooling also environmentally friendly and energy efficiency. Malaysia with tropical climate condition where the average day drive bath temperature around 32 degrees Celsius, wet bath temperature 25 degrees Celsius and relative humidity 62% respectively. The lower relative humidity of daytime hour is indicates that evaporative cooling system can potentially be used to lower indoor temperature. Air conditioning energy consumption account for 46% of total energy consumption in typical office building in Malaysia. Therefore, there is a need to study alternative cooling solution that require low operational energy and operative cooling are candidate. Literature review. In Malaysia, Muhammad, Sulaiman, Sofian and Al-Abidi 2003 was doing experiment performance of the direct evaporative cooling operation in Kuala Lumpur. The result showed the output temperature of air varies between 27.5 degrees Celsius to 29.5 degrees Celsius, while the cooling capacity is between 1.384 kilowatt and 5.358 kilowatt. Julius and Ong study the effect and usefulness and evaporative cooling in Malaysia. The investigation was conducted to evaluate the effectiveness of evaporative cooling in providing human thermal comfort based on finger predict means word. The results show that the evaporative cooling can reduce dry bath temperature up to maximum 9.9 degrees Celsius and suggests that evaporating cooling system may be a possible cooling solution in Malaysia to give the space low heat gain. The smaller of F number, the more feasibly the evaporative cooling system. F is indicate the evaporative cooling potential to give thermal comfort. In Malaysia, the average daytime F factor is 18, which is exceed the recommended margin. An evaporative the environment conditions such as inlet temperature and relative humidity, pad material, pad thickness and density, pad air phase velocity, and water flow in pad was the factor that can affect the performance of the aerating cooling system. An aerating cooling system can become more effective when temperature are high, relative humidity is very low, water is available for the purpose, and air conductive. Air is conductive. This is schematic diagram of direct cooling, aerative cooling. The experiment was doing at College Community Kota Marudu, Sabah. Location is 9.0367 knots and 119.11 Earths at 8 p at 10 a.m. to 3 p.m. at October. The direct aerative cooling using a fan 21 watt, pump 10 watt, and body was made from metal. Honeycomb cooling pad was using, and the large of is 26 centimeter wide, 20 centimeter, and thickness of 5 cm. We are measuring air temperature, relative humidity, inlet and outlet. We using two type K thermocouple, dry and wet bath temperature. We using slang pyrospecicometer, air velocity using anemometer, and solar radiation using pyrometer. This is the photo of direct aerating cooling and its pad. Performance evaluation. DEC cooling efficiency is the ratio of the temperature difference between dry bath and wet bath inlet temperatures. Dry bath temperature of outlet air can be calculated using equation from Watt, RJ, and Brown, WK, 1994. Cooling capacity is the rate where the heat is removed while temperature remains constant. Cooling load or cooling capacity is calculated using equation 3. And we also calculate the feasibility index F. Result and discussion. The construct system was tested to assess its performance. The experiment reading of dry bath temperature of the inlet and outlet air, solar radiation, saturation efficiency, and cooling capacity. During the experiment, inlet air conditioning of the dry bath temperature was between 29.5 degrees Celsius to 33.5 degrees Celsius, where air relative humidity was between 98% to 77%, and solar radiation was between 333.5 to 903.7. The average air velocity during experiment was 4.55 meter per second, and the water mass flow rate was 0.2548 kilogram per second. This is the table 1 show is the experiment data and the performance parameter. So from here we are measuring the T1, TWB, and T2, and we are calculate efficiency, effector, and radiation saturation effectiveness. This is the value of experiment test for average, maximum, and minimum. For example, dry bath temperature, this is T1, average is 32.20, wet bath inlet 23.22, dry bath outlet 25.71, solar radiation average 920.88, efficiency around 75 to 71.95%, feasibility index around average 40.42, cooling capacity 1.84, air velocity 4.55, and relative humidity 71.53%. This is figure 3 show the graph of dry bath inlet, dry bath outlet, and wet bath inlet with the time. It is possible to obtain the maximum temperature difference up to 7.6% at relative humidity of 42.5% and minimum temperature difference up to 2.1 degrees Celsius at relative humidity 81.1%. The performance of saturation efficiency with the time is illustrated by graph in figure 4. As we can see, the performance and average cooling was evaluated from the value of saturation efficiency. The outlet dry bath temperature was a direct effect on saturation efficiency of the average cooling. The variance of saturation efficiency with time is shown. In figure 4, the efficiency is between 67.23% to 77.27% range. Numerous research has proven that saturation efficiency of commonly used cooling pad material fall with 50% to 90%. The maximum saturation efficiency was recorded at the time to 30 p.m. while the dry bath temperature and relative humidity of 36 degrees Celsius and 74% respectively. The saturation efficiency decreased with increased the mass flow rate of the air. This is the graph of variation of cooling capacity and variations of visibility index. The variation of cooling capacity with the time of test is shown in figure 4. The graph plot shows that the cooling capacity varies between 1.3 to 5.3 kilowatt. The maximum cooling capacity was recorded at time 1:50 p.m. while the minimum cooling capacity was recorded at 10 a.m. The cooling capacity was result from the drop of in the dry bath temperature of air. The variance of visibility index with time is shown in figure 6. The F factor value remain relatively constant between 10 a.m. to 3 p.m. range from 11.89 to 70.84. This value is well below the F of Malaysia average Malaysia daytime with F is 18. The F value peak between 10 to 10:30 a.m. The low the F number, the more visibility the everything cooling become. Hence, the most effective time for the everything cooling operation is from 11 to 1:45 p.m. In the other word, the greater the difference between T1 and TW, the greater the everything cooling effect. For the conclusion, everything air cooling system is energy efficiency and can be used as an alternative to the conventional system and has a large application potential to provide thermal comfort by cooling and humid of the ambient air at reduced operation cost. It's not only cheap solution but also sustainable and environment friendly for air conditioning. The experiment study was carried out to evaluate the performance of the direct everything cooling in humid region. Experiment results show that application of direct everything cooling in hot and humid region has successfully decreased the dry bath temperature. The saturation efficiency varies from 67.23% to 77.27% and the cooling capacity range is between 1.09 to 2.08. For more effective, the direct air cooling can be applied in humid place like Malaysia by drying the air before the everything cooling process using the desiccant humidification concept. The everything air cooling system is energy efficiency and can be used as alternative to the conventional system and has a large application potential to provide thermal comfort by cooling and humidification of ambient air to reduce operation costs. That is for my presentation. Thank you very much.